A ladder 12 meters long leans against a wall. So this is my ladder. The foot of the ladder is pulled away from the wall at the rate of 1 over 2 meters per minute. So this is the foot of the ladder. It's being pulled away from the wall at the rate of 1 over 2 meters per minute. Okay, so this rate we can say it's dx, right? The change in x. So since it's with respect to time, we can say it's dx dt. Then the information is saying at what rate is the top of the ladder falling when the foot of the ladder is 4 meters from the wall. So the distance here from the between the wall and the foot of the ladder is 4 meters. So we can say in this horizontal axis we'll label it x, then in the vertical axis we'll label it y. Then the change in x, we say it's dx over dt. Then the change in y is going to be dy over dt. Then this one, since it's a uniform length, we have a 12 here, where we can say it's equal to c. So using this information, we need to find the rate at which the ladder is going to be falling in the y-axis. So we can start with Pythagoras theorem, where we say x squared plus y squared is equals to c squared. Here we don't have the value for y, but we have the value for x, and we have the value for the length of the ladder. So using these two, the length of the ladder and the x, we can find the value for y, meaning that we're going to have we're going to plug in the formula. We're going to have 4 squared plus y squared, which is equals to 12 squared. This will give us our y squared, which will be equal to 144 minus 16. When you punch on your calculator, you get y squared, which is equals to 128. When you square root, you're going to get a positive value of 8 root 2. So using this value now as the value for y, we can come and find the rate at which it's changing. Okay, so to find the rate, we differentiate this equation. So we are going to have x squared plus y squared plus which is equal to c squared. Differentiating this equation, we have 2x. Of course, we are differentiating with respect to time, so it will be 2x multiplied by dx dt. Then plus differentiating y with respect to time, we are going to have 2y dy dt. This will be equal to, our c is a constant, which is 12. So we can say the differentiation of 12 is 0. Having this equation, we can simply divide throughout by 2. We're going to have x dx dt plus y dy dt, which is equals to 0. Our target is to find the rate at which it's falling in the y-axis. So we take our x dx to the other side of the equation, meaning that we are going to have y dy dt, which is equal to negative x dx dt. With this, we can plug in the values. For y, we found it to be 8 root 2 dy dt, which is equal to our x, we found it to be 4, given in the equation. Then the rate at which it's changing is also given in the equation as 2 meters per minute. Using this information, we can find our dy, where we say dy dt is equal to you divide throughout, or say you multiply throughout by 1 over 8 root 2. When you multiply here, it's going to cancel out. When you multiply here, you're going to have negative 4 multiplied by 1 over 2, everything over 8 root 2. So a 4 here, we get 1. A 4 here, we get 2. Meaning that our dy dt is going to be negative 1 over 2, everything over 2 root 2. Simplifying this, it's giving us negative 1 over 4 root 2 meters per minute. This is the rate at which y is changing, or at which it's falling down.